This is the lesson for topic 3.14, which is graphing polar functions, and these images are from your notes. But what we're going to do is graph a polar function where the input value is the angle theta, and the output value is a polar function. In this case, we're going to start with the function r equals 6 times sine of 2 theta. When we graph a polar function, we input a theta value, and we calculate the r value, which is the directed distance from the origin or the pole. It's called the pole on the polar coordinate plane. And basically the graph is going to be all of the points that satisfy the function. You notice over here in the table of values that we gave the theta value second and the r value first. That is because of the convention that we write all polar coordinate points in the format r comma theta. So if I plug in 0 for theta into my r function, I get 6 times sine of 0, which of course is going to be 0. Then I substitute in pi over 6, and I get 6 sine of pi over 3. And of course, sine of pi over 3 is rad 3 over 2, so this will get me 3 rad 3. If I do 6 sine of pi over 4, 6 sine of 2 times pi over 4, that's 6 sine of pi over 2, which is 6. When I sub in a pi over 3, I have 6 sine of 2 pi over 3, which gets me again to rad 3 rad 3. Plugging in pi over 2 gets me to sine of 0, which is 0. And I can keep going around the unit circle. I'm going to go ahead and input the values while I pause the video. All right, I went ahead and completed my table of values just by substituting in each theta into the equation, and you'll see a lot of symmetry. You'll see a lot of 6s, a lot of 0s, and a lot of 3 square root of 3, and then the negations of such. So let's go ahead and plot the points. The first point is the point 0, 0. So at angle 0, I have an r value of 0. That is on the pole. Then at pi over 6, which is right here, I have 3 times the square root of 3, which is about 3 times 1.7, so about 5.1. That'll put me about right here. And then at pi over 4, I pop out to 6. At pi over 3, I go back to 3 rad 3. And at pi over 2, I come back down here to 0. Now I'm going to go to 2 pi over 3, which is this angle here, but I have to go in the negative direction, about 5.1, the negative 3 rad 3. And then from pi over 4, I go to negative 6. And then from 5 pi over 6, I go to negative 3 rad 3. I'm going to go ahead and just start connecting some points so you see, but it looks like this. And then it comes down here into the fourth quadrant. And then this point comes from pi, or 0 pi, input of pi, output of 0, gets me back to the pole. Then 7 pi over 6, my r values are positive again. So down here at 7 pi over 6, I come out to 3 rad 3. At 5 pi over 4, I go to 6. 4 pi over 3, I'm at 3 rad 3. Then I come back to the pole. So I have that loop. And then my last loop, again, I work with negative r's. So I come down here to 5 pi over 3 as the terminal side, but then I go backwards up to negative 3 rad 3. 7 pi over 4 is down here. I go backwards to negative 6. 11 pi over 6 is down here. I go backwards to negative 3 rad 3, and then I come back to the pole. So just to put it in perspective, I graphed this quadrant first, then I graphed this, and then I graphed this, and then I graphed that. It does not necessarily go in order of quadrants. It goes in order of increasing theta. By the way, this figure is called a polar rose. You are not required to know that. It's just an interesting fact. Over here, we have several interesting figures that come out in polar coordinates, polar graphings. This is a cardioid because it looks like a heart. Here is a 7-leafed rose. This is called a lemniscate, which is the infinity symbol, and this is a spiral. Again, you're not required to know any of the shapes, but they're just interesting to see. Okay, so we graphed the polar function on the polar coordinate plane. Let's take a look at the same function written in terms of x and y. Before, I had r equals 6 sine of 2 theta, and I graphed it on the polar plane. Now I've got an input value of x and an output value of y. Here I'm going to have a midline that's on the x-axis. I'm going to have an amplitude of 6. So let's assume these go by 2. My amplitude takes me up here to my max and down to -6 as my minimum. And then my period, which is 2 pi over this b value, so 2 pi over 2 is pi. So I start for sine at the origin, I head up, I come back to the midline halfway through the cycle, I go down to the bottom, and then I go back to the midline. So this is one period here, and then of course I could map in a second period of this sine function. So why did I just take that polar function and map it on the rectangular coordinate plane? It's because there's a lot of similarities between the functions. For example, if I pull down the graph, on the polar graph, I started with, sorry, I'm having a little bit of trouble. Okay, I started here and I moved outward. I moved away from the origin from 0 to pi over 4. Notice on the rectangular graph, I'm moving away from the x-axis on 0 to pi over 4. On the polar graph, I move toward the origin on pi over 4 to pi over 2. On the rectangular graph, I move toward the x-axis on pi over 4 to pi over 2. So that's going to hold every time. On a polar graph, as the graph moves away from the pole, that is akin or the same thing as on a rectangular graph, the graph moving away from the x-axis. The graph moving toward the pole on the polar graph moves toward the x-axis on the rectangular axis. That is going to help us answer multiple choice questions. So here's an example of the polar function r given by f of theta equals 3 cosine theta plus 2. And they want us to identify which graph matches. What I like to do is start by graphing this function on the xy plane. So I'm going to put in this y equals 2 here for my midline. And then I have a maximum up here at 5. And I'll have a minimum down here at -1. And my cycle here, my period is 2 pi because I have a coefficient of 1 in front of x. And with cosine, I start at the max and I end at the max. Halfway through, I go to the min, and halfway between the max and the mins, I cross the midline. So I have here one cycle or one period of my cosine graph. So why does this matter? Well, first of all, this section down here where my x values go negative actually mean that my r values go negative on my polar graph, and that is going to produce what we call this inner loop. That means that C and A cannot be my answers. Because of those negatives, I must have an inner loop. Secondly, because my y value goes all the way up to 5, that means my r value must go up to 5. So the only two graphs where the r value goes to 5 are here and here. We already said we can't be this one because it doesn't have an inner loop. Therefore, D has to be my answer. So basically, the other thing that I should say, my thought questions were, how does the max value help decrease your answer choices? Well, the max value here was only 4, so it can't be that. And the max value here was only 4. And then the minimum value tells me about the negative r value and the fact that I had to have an inner loop. And that is it for topic 3.14.